Okay, let's solve this problem of one dimension, kinematics in one dimension. So the problem says the following. An object is launched vertically in the upward direction after 4.2 meters above its initial position. It loses 60% of its initial velocity. Write the equation of motion of the object. Calculate the initial velocity. What is the maximum height reached by the object? Well, it's clear that this object is, or this situation is a free fall, falling body or free falling object. A free falling object is the following. It take the y-axis, and this is the ground. This is y equals 0 or y0 equals 0. So the free falling object is when you, for example, you throw an object upward with an initial velocity v0, and then this object will go and come back. Okay, so it will go and come back. And the question here is write the equation of motion of the object. Well, it's clear that this motion is happening in the vertical position, and since our y-axis is along the is upward, the positive axis of the positive direction of the y-axis is upward, so the acceleration is equal to minus g. There is only one acceleration along the y-axis that is due to the gravitation strength, and g is just the gravitational strength. Okay, and then if we integrate, the velocity at any point will be equal to the initial velocity minus gt. And then if we integrate again to find the position, the vertical position, if there is an initial velocity, initial position, then we can take it into account, and then we integrate the velocity, which is plus v0t, minus we integrate the third term, which is this one. So this is the equation of motion in general. Now, it's clear that in this situation, there is no initial velocity, position. So there is no initial position. So this one will be now. Why there is no initial position? Just because we started our motion. We choose to start our motion the moment when the object is released from the ground, from y equals 0. Okay, so let's look at the keywords on this object, on this problem. So the object is launched vertically, okay, with an initial velocity. After 4.2 meters above the initial position, it loses 60% of its initial velocity. Well, now let's do the situation. Let's assume this is the y1 equal to 4.2 meters. So y1 will be reached at time t1, and it will have velocity v1. Okay, so at that velocity will be 40% of the initial velocity, because the velocity would have lost 60% of its value. So let's write the equations. I know at t, so y1, which is 4.2 meters, of course we are talking about question B, the time is t1, and the v1, which is the velocity at t1, is equal to, first, it is equal to 0.4 v0. Why? Because the velocity lost 60% of its initial velocity. And it is also equal to the equation. I will call this one equation 1 and this one equation 2. So using equation 1, it will be v0 minus gt1. So now let's get t1 from here. So it can easily see that t1 will be equal to v0 over g times 0.6. So I will call it equation number 3. This is just a consequence of combining v0 alone together and isolating t1. Now this equation 3, I can get it, plug it into 2. Okay. So equation 3 in equation 2, okay, it gives me y1, which is already equal to 4.2 meters. It is equal to v0t is equal to v0 t1. T1 is v0 g times 0.6 minus 1 half g t1 squared. T1 squared is v0 over g times 0.6 everything squared. Now you can easily see that y1, which is equal to, well, I can get rid of it, 4.2. You can easily see that 4.2, which is y1, I will call it y1, I still want to keep y1, is equal to v0 squared times 0.3 divided by g. So this is what you get from here. So all what you do is just distribute this, and then you just combine, and you can find that it's equal to v0 squared times 0.3 divided by g. So this will give me the initial velocity as a function of y1. So the initial velocity v0 squared will be equal to g y1 divided by 0.3, which means v0 is equal to the square root of g y1 over 0.3. Okay, and the final result will be 4.2 meters times 9.8 divided by 0.3. This will give me 11.7 meters per second. This is the initial velocity in this case. Okay. Now, what is the last question? The last question is to calculate. So the last question is, what is the maximum height reached by the object? Well, I know that the maximum height corresponds to the velocity equal to 0. Okay, so the first thing I would need to do is to calculate at which time the velocity is equal to 0. I know that the maximum height is reached when the velocity, I will call it maximum, or t2, is equal to 0, which is also equal to v0 minus gt. Well, this means that the time t2, or the time at maximum, is equal to the v0 divided by g. We have v0 because we already found it, and we have g. Now, this equation, I will call it equation 4. I will plug it into equation 2, which means the equation of the motion, of the position. So I know that, well, y max will be equal to v0 times t2 minus 1 half gt2 squared. Okay. Okay. So this means that y max is equal to v0 squared over 2g, which is the maximum height will be reached at 6 or 11.67 squared divided by 2 times 9.8, and y max is equal to 6.98 meters. This is an example of the free falling object. Okay,